Greetings, Saxon Algebra 2, Lesson 102. This is a meaty, important, interesting-ish algebra problem that often shows up on standardized tests because everybody forgets how to do this, even though it's not all that hard. We're going to talk about sums of functions. That's our first topic, so maybe I'll just write that for now. We're also going to talk about products of functions. So we're going to add and multiply functions. Here's what I'll do. I'll amend my title so I don't have to write it all twice. Sums and products of functions. First, we'll do sums. Okay, sums means adding. So instead of a preamble, let's jump right in because I can show you this as we're doing it. We're given two functions, the h of x equals x plus 3 with the domain of the reals. And then we have a theta of x. Well, it's just the name of the function. It doesn't affect the math at all. X squared minus 6, domain equals the integers. And we're supposed to find the h plus theta, whoops, I didn't make a theta, I made a cube, h plus theta of 2. Okay, so what this means is it wants us to add together these two functions and then find out what the value is if we use 2 in place of the x. Now, there's two ways that we can do this. The first way is to calculate way to do this is to calculate the two functions separately and then add the answers. So that would look like this. First we find the h of 2, which would be equal to 2 plus 3, right? I'm using this function. 2 plus 3, so that would be 5. And then we'd find the theta of 2, which would be 2 squared minus 6. I'm not using a bucket only because that's a positive number. If it was negative, I'd use one. This is 4, so 4 minus 6 equals minus 2, right? And so if we add then 5 plus minus 2, those are our two answers, we would get 3, and we would say the h plus theta of 2 equals 3. Okay, that's the correct answer found by calculating each function separately and then adding the answers. The other way to do it is to add the functions, then calculate. And that would look like this. We would first calculate the h plus theta of x by just combining them. And we would take x plus 3 plus x squared minus 6. We just smush it all into one thing. And then I can just reformat this. I can combine the like terms, and I can get x squared plus x minus 3 would be our combined function. Now we plug in the 2, and we would get 2 squared plus 2 minus 3. This is 4. 4 plus 2 is 6 minus 3 equals 3. So here we get that the h plus theta function of 2 equals 3. And that is exactly what we got last time. So what we see is that these two methods both work. Some students think one is easier than the other. It's really your preference or what John tells you to do. Notice that our answer is acceptable for both domains, so we don't have to worry about that. Let's try another one. You can hear my chair squeak when I stand up to make sure that my book is still straight in the frame. Gracie's lying on the floor in the sunshine, sleeping. Okay, here we go. H of x equals x plus 3. That's the same as last time. Oh, my equal sign. Domain equals the reals. And when we're adding these, sometimes just above and below each other. This time we have a g of x that equals 2x squared plus 5. Domain equals negative integers. Oh, okay, that's kind of a fussy domain. So we're going to have to be careful about that, right? And we're supposed to find the h plus g of 5. Now, it would be a simple enough thing to plug 5 into both of these, calculate separate answers, then add them together. It would be a simple enough thing, right? We would go 5 plus 3 equals 8, and then we would go 2 times 25 plus 5. This would be 50, and this would be 55. And we could add those together to get 63. Or we could do it separately. We could go 2 times 5 squared plus 5 here plus 5 up there plus 3. I'm adding them together, but I did the bottom one first for reasons I can't explain. This would be 50. This much is 50, 63. We get the same answer. However, this is method 1, this is method 2. We shouldn't do either of those because we're being asked to put a 5 into these functions, and the domain of one of them is limited to negative integers. So the actual answer is not 63. The actual answer is empty set or null set, because 5 is not a valid domain for the second function, so we can't plug that in. Tricky, right? We didn't even have to do this work. In the lesson here is always check your input, the number that you're trying to put into the function, check it against your domains before you proceed. Save yourself a little trouble. Okay, the second half of the lesson is about products of functions, and as you may guess, with sums of functions, we added the functions. With products of functions, we're going to, wait for it, multiply. Yes. And it works exactly the same way in that we have 2 options. We can either do them separately and then combine them at the end, or we can actually combine the functions. I'll do it both ways. We're supposed to take these 2 functions. Whoops. The h of x is equal to x plus 3. Domain equals the reals. I'm just going to abbreviate as an R because I'm going off the page. And the g of x, I'll use more space for that, equals x squared minus 6. Domain equals negative integers again. Okay, so this time we're prepared for John's tricks. Let's see what he asks us to put in. He wants us to find the h times g of negative 4. Okay, I feel better about this because negative 4 works in our pair of domains. It works for both of them. So we're fine with using this. So method 1, I'm going to flip the page, and that's going to be a big pain. Well, let's just start it over here and see how much space we have. The first one is where we use the function separately and then combine at the end. So we would find the h of minus 4 would be equal to minus 4 plus 3. See, I'm just plugging it into this function, and I get minus 1. The g of negative 4, negative 4, not 14, equals x4 squared minus 6. 4 squared is 16. And that would be 16 minus 6 equals 10. And then remember, we're not adding these functions, we are multiplying them. So I would multiply 10 times minus 1 to get minus 10 as my answer for the h times g of -4 using the first method. Now, this one, a lot of students consider a pain in the neck because we have to multiply these two. We have to take x squared minus 6, I'm putting that one on top, x plus 3, and we have to multiply this. I'm going to multiply it on the other side. X squared minus 6 over x plus 3, double checking to make sure that's right, yes. Okay, now we do the dance, x cubed minus 6x plus 3x squared minus 18. Oh gosh, that's a lot, isn't it? That is a lot. I want to switch these two around. I want to have x, so I'm going to rewrite it as x cubed. I'm not going across an equal sign, I'm just rearranging so I don't have to worry about signs. 18, not 16. Okay, and then we want to find the hg of, this is what we're looking for, the hg of minus 4. So we're going to plug minus 4 into this, so it would be minus 4 cubed. Notice that I'm using buckets because I have a square on my plug-in value. I don't want to confuse myself on that. The minus signs. Okay, 4 cubed is 64, right? 16 times 4, yep. And this is going to be 16 times 3. I just looked at that and was like, yeah, there's a 4, 2, 6. Okay, 16 times 3 is 48. And that's going to be positive because this negative goes positive when we square it, and that's positive, so it's plus 48. This becomes plus 24. Those two go together to make a positive. And then we have negative 18. I'm going to combine the positives and the negatives. This would be minus 82 plus 72. And that equals minus 10, which is the same answer we got right there. I didn't box it, I circled it, or squiggled it. That's the right answer, and we got it either way. Now, when it comes to products of functions, a lot of students find this, the place where we multiply the binomials, and they find that to be disgusting. Yeah, I agree. Excuse me, it's not the end of the world. We can do it either way. I agree that this maybe is less attractive, but either way works. Example 102.4. This time we're supposed to find the f times g of minus 4, where the f of x, we've had f of x equals x plus 3 every time. Domain equals the reals, at least I think. And this time we have the g of x, which is equal to x minus 5. And this domain is limited to positive integers. And so now we've learned our lesson. We always check our input value against the domains, and we find out, that's not going to work. We can immediately quit with the problem and give this as our answer set because we have a domain violation here. This does not work as a positive integer. It does work as a real, but it's got to work for both. So this is our final answer. Always check your input value against your domains before you put any more work into the problem. That is lesson 100. Remember it. It sits on lots of tests like SATs and AccuPlacers. This is a common type of problem in that setting. So find a special corner of your brain and tuck it in. See you next time.